Imagine this. A robotic explorer millions of miles from home rolls across the dusty red landscape of Mars, its cameras scanning every detail, its instruments probing ancient mysteries. Then, in a single moment, its sensors pick up something no one expected. What could these rocks possibly reveal about a planet that has captivated humanity for centuries? Could they hold clues to ancient life? Could they upend everything we thought we knew about Mars? These questions gripped scientists back on Earth as NASA's Perseverance rover uncovered something shocking during its first year on the Martian surface. This is the story of how seemingly ordinary rocks turned into extraordinary revelations. Have you ever wondered what's up there that we can't see? I'm Umbra, and I'll reveal it all. Keep watching. When Perseverance landed on Mars in February 2021, its mission was ambitious: to search for signs of ancient microbial life, study the planet's geology, and collect samples for a future return to Earth. It touched down in Jezero Crater, a region once thought to be a vast lake billions of years ago. Scientists were confident this area, chosen for its rich history of water activity, would hold the secrets to Mars's ancient past. But what Perseverance found left them questioning much more than they had anticipated. The first clue came early in its mission, as Perseverance's cameras started capturing the crater floor. At first glance, the rocks seemed unremarkable, just the usual basaltic crust seen elsewhere on Mars. However, upon closer inspection, the rover's advanced tools revealed something surprising. The rocks were not just volcanic in origin, they contained tiny pockets of minerals formed in water. This was the first jaw-dropping moment. These rocks weren't simply the product of volcanic eruptions, they had interacted with water for extended periods, suggesting that Jezero Crater had been wet and had experienced long-term aquatic environments. Scientists back on Earth were thrilled. This discovery wasn't just about water, it was about habitability. The interaction between water and rock can create the perfect environment for life to thrive. Could Jezero Crater have been home to Martian microbes billions of years ago? If so, what happened to them? Did they leave any trace behind? These questions fueled the next phase of Perseverance's exploration as the rover moved deeper into the crater. Then came the second shock. Perseverance drilled into the rocks and extracted samples, allowing its instruments to analyze their composition in detail. What they found was unexpected: the presence of organic molecules. These carbon-based compounds are the building blocks of life as we know it. Although organic molecules can be formed through non-biological processes, their presence was a tantalizing clue. They suggested that Mars had the necessary ingredients for life at some point in its history. The implications were profound. If life once existed on Mars, could it still exist today in some hidden corner of the planet? Or were these molecules merely remnants of a long-dead biosphere? But the surprises didn't stop there. As Perseverance climbed the edge of the ancient river delta within Jezero Crater, it encountered rock formations that told a story of catastrophic flooding. These layers of sediment, stacked like the pages of a book, revealed that powerful floods had once swept through the region, reshaping the landscape. This discovery hinted at a dynamic history for Mars, a planet that might have been far more Earth-like in its distant past. The rover's cameras captured stunning images of these formations, sparking widespread excitement in the scientific community. The story of Jezero Crater's rocks wasn't just about water and organic molecules, it also became a tale of time. As Perseverance's instruments measured the isotopes in these rocks, scientists were able to estimate their age. They discovered that these rocks were over 3.5 billion years old, formed during an era when Mars was much warmer and wetter than it is today. This realization added yet another layer of intrigue. Mars might have been a planet teeming with activity and potential for life, while Earth's own biosphere was still in its infancy. Could this mean that life, at least microbial life, might have had a head start on Mars before flourishing on Earth? Meanwhile, the rover's audio recordings added an eerie dimension to its findings. Perseverance captured the first ever sounds of Martian wind, offering a visceral connection to the planet's present environment. These recordings, combined with the visual and geological data, painted a picture of a planet that is both alien and strangely familiar. Mars's story, it seemed, was far more complex than anyone had imagined. As Perseverance continued its journey, its mission to collect samples took on even greater importance. Each rock it drilled into was carefully sealed in a tube to be stored until a future mission retrieves them for study on Earth. Scientists hope that these samples will contain definitive evidence of whether life ever existed on Mars. It's a high-stakes gamble, but one that could redefine humanity's understanding of its place in the universe. The final shock of Perseverance's first year came when it detected unexpected patterns in the Martian atmosphere. Its sensors picked up traces of methane, a gas often associated with biological processes on Earth. While methane can also be produced through geological processes, its presence raised eyebrows. On Earth, methane is quickly broken down by sunlight, so its detection on Mars suggested it might be actively replenished. Could there be subsurface microbes releasing methane even now? Or was this methane trapped in ancient ice, slowly leaking out as temperatures fluctuated? Each discovery by Perseverance has added a new layer of mystery. The rocks in Jezero Crater have gone from being geological curiosities to becoming the keys to unlocking Mars' deepest secrets. They tell a story of water, habitability, organic molecules, and perhaps even life. But they also raise profound questions about the fate of Mars. What caused the planet to lose its atmosphere and water? Could the same fate await Earth one day? These are not just questions for scientists, they are questions for all of humanity as we look to the stars and ponder our future. In its first year, Perseverance has done more than gather data. It has reignited our curiosity and our sense of wonder. Its discoveries have reminded us why exploration matters. Mars, a cold and desolate world, has revealed itself to be a planet with a vibrant past, a planet that may still hold secrets waiting to be uncovered. And with every rock analyzed, every sample collected, Perseverance brings us closer to answering the ultimate question: are we alone in the universe? The journey is far from over. Perseverance continues to explore, to drill, and to discover. But its first year on Mars has already made history. The rocks that shocked scientists the most have not only revealed Mars's rich and complex history, but have also opened the door to a future where humanity might one day set foot on the red planet. Until then, we watch, we learn, and we dream. Because on Mars, the story is just beginning. The exploration of Mars by Perseverance is a monumental feat in human history, one that combines technological brilliance with profound scientific curiosity. The rover's tools, including its Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals, spectrometer and pixel, planetary instrument for X-ray lithochemistry, have allowed scientists to peer into the fine details of Martian rocks. Sherlock's ability to identify organic compounds through ultraviolet light and PXL's capacity to analyze the elemental composition of rocks have transformed our understanding of Mars in just a short span of time. One of the most dramatic moments came when Perseverance used its MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, instrument to produce oxygen from the carbon dioxide in the Martian atmosphere. This milestone was a significant proof of concept for future human missions. If astronauts are ever to live and work on Mars, the ability to generate oxygen for breathing and as a component of rocket fuel will be critical. MOXIE's success not only advanced science, but also strengthened humanity's aspirations to one day become an interplanetary species. As the rover's journey continued, it encountered evidence of ancient shorelines and deltas within Jezero Crater, revealing a landscape shaped by rivers and lakes. These discoveries challenge previous assumptions that Mars's hydrological history was short-lived. Instead, they suggested that water flowed on Mars for a much longer period, potentially providing a stable environment for life to develop and thrive. The layers of sediment captured in these deltas became a time capsule, preserving Mars's geologic and environmental history like a diary written in stone. Perhaps the most awe-inspiring aspect of Perseverance's mission is its role in humanity's quest to answer the age-old question: are we alone in the universe? By seeking biosignatures in rocks and soil, the rover attempts to uncover traces of life that may have existed billions of years ago. Even the faintest hint of microbial fossils or chemical signatures would have profound implications for our understanding of life beyond Earth. The discoveries made by Perseverance during its first year have not only captivated scientists, but have also inspired millions of people around the globe. The rover's findings have sparked debates, fueled imagination, and brought the mysteries of Mars into living rooms and classrooms everywhere. As humanity watches the rover navigate the harsh Martian terrain, we are reminded of the resilience and ingenuity required to push the boundaries of exploration. Looking ahead, the samples collected by Perseverance will be returned to Earth by a joint NASA-ESA mission planned for the 2030s. These samples are expected to provide unprecedented insights into Mars's geology, chemistry, and potential biology. Scientists will analyze them with tools far more sophisticated than those aboard the rover, potentially uncovering hidden secrets today. Perseverance's mission is more than just Mars. It's about the spirit of exploration and the desire to answer questions that have puzzled humanity for generations. The discoveries made in its first year have laid the groundwork for future missions and brought us closer to understanding not only the history of Mars, but also the broader narrative of our solar system. With every rock it analyzes, every sample it collects, and every mystery it uncovers, Perseverance reaffirms our place as explorers, adventurers, and seekers of knowledge. Thanks for watching till the end. We hope you found this video insightful and packed with value. If you did, don't forget to hit that like button. It really helps us out. Share this video with friends or anyone who could benefit from it, and be sure to subscribe to our channel for even more tips, tricks, and expert insights coming your way.